Hi, in this video, we will learn how to use the integration to find the arc length. Not only the arc length, we also can find the arc length function by using the proper integral. So what is arc length in the first place? In simple, if you want to find the distance of the blue curve here, then you are going to find the arc length. It's much more easier for us to find the distance of this straight line instead of the distance of the curved line. If we zoom at this region, if you have more points located to the curved line, we can see initially it's just 2 points, then you have 3 points, 4 points, and so on. Then you can see the red color, which is the straight line, approximate the curve better and better. In this case, we know that by reducing the step size between these 2 points, then the accuracy of the straight line to approximate the curved line here will be increased. Where you can see that the step size delta x between the point 1 and point 2 are large initially, and for the last case here, the delta x between 2 points are smaller. Therefore, the red line, which is straight line, approximate the blue curved line better. So if you further reduce the step size, delta x approximate to 0, then you will obtain infinity segment on this curve.
In this case, the distance of the blue curved line, which is the arc length, can be computed by using the numerous infinity straight line. Let the pi to be the first point and then pi minus 1 to be the second point. For example, when your I is equal to 1, then you have the p1 equal to x1, y1, which is equal to this point. Then the second point will be p0 equal to x0, y0, which is equal to this. To find the distance of the straight line between these 2 points, we can form a triangle. And from the triangle, we can take the delta y square here plus the delta x square here and take the square root, then you obtain the resultant. So the distance of a straight line between 2 points can be written into this formula, where this is the delta x and this is the delta y. From here we understand that when the delta x is small enough, the segment will be approximate to infinity. So in this case, the summation of the distance of the straight line can be equal to the distance of the curved line. So in this case, we can compute the arc length by using the summation of the distance of the straight line. For example, in this case, you want to find the arc length of this curve, which is from A to B here. So we can actually represent this curve by using straight line. So in this case, the straight line can be computed by using this formula, and since you only have 2 points, therefore the end segment is equal to 1. In this case, the distance of the straight line is not equal to the curved line. To increase the accuracy, let's increase the segment. So you have infinity segment here, and then you take the summation of all the straight line between them. Therefore, in this case, our limit for n is approximate to infinity. By doing this, we can find the arc length of the curve by using this formula. The summation of infinity segment can be represented by integration, where you have learned the integration is analog to the summation before. Let's continue to discuss how can we further simplify this term. We know that the absolute of pi minus 1 is the distance of the straight line between these 2 points. And we can find this distance by using this formula, where you take the delta y square plus delta x square and take the square root. We can compute the gradient here by using this formula, delta y divided by delta x. And if the fx function for the actual curved line that you want to compute the arc length is given, and if you compute the slope from this function, let's say you take the derivative of it at any point of x here, then you will have a particular point of x which is given in this format, where you can see over here the slope of the f prime x is equal to the slope of delta y over delta x here. However, this particular point of x is unknown, which makes this formula invalid. For example, if you choose the point at here or here, the slope will be different with the delta y over delta x. To ensure that this formula is valid, the delta x, where in this case, the approximation curve will be in the same direction with the actual curve. In this condition, the formula here will be valid because the limit here is followed. Then we can obtain the delta y equal to f prime x multiplied with delta x, and if you substitute inside this formula, you should obtain this equation. Also, you can express the delta x equal to delta y divided by f prime x and substitute it inside this formula. After substitute the delta x here, then you should obtain this equation. Then you can take the delta y square outside the square root to obtain delta y. So this is the two formula that we obtained so far to calculate the distance between 2 points. For the first case, you can see that the delta x between these 2 points is too large. Therefore, we say that we have a poor step size. So you can see that the distance of this straight line does not represent the distance for the curved line. One of the reasons is the slope of this straight line is equal to delta y over delta x and is not equal to the f prime x by using this point. So you can see the slope here are not the same with the slope here. Therefore, if you use the wrong slope for the calculation of the distance here, it will be wrong. So we need to continue to reduce the step size, where you can see the delta x here is very small up to a limit where your delta x approaching 0. If this limit is followed, then delta y over delta x here can be written in dy over dx, which is the slope of the approximation curve. In this case, the approximation curve will be equal to the actual curve here. If this limit is followed, then we can further simplify these two equations into this, where you can see the slope can be written in the dy over dx form and the delta y can be written in dx form. In summary, to find the arc length of the curved line here, we know that it is equal to the integration from the lower limit a to b. And we know that the integration here is analog to the summation of numerous straight line, where you take the summation of all the distance for the straight line, which can be equal to the square root of dx squared plus dy squared. So this is the distance of the numerous straight line. So we can take the dx squared out to make it 1, and you need to divide with the dx squared, which gives you this. So at the outside here, the square root here can be cancelled, so this term can move to back here to obtain this formula. So this is the famous formula that we use to compute the arc length. For example, in this case, if the curve here has the distance equal to 8, then you should obtain the arc length equal to 8 from A to B here. If we want to find the arc length at any particular x here, let's say you want to know what is the arc length from A to x1, which is this, or you want to know what is the arc length from A to x2, which is this. So it's not efficient for us to keep repeating this formula to compute the arc length at numerous points like this. So in this case, we will find the arc length function by using this formula. So in this case, you can see the formula are similar to the previous one here, just that you replace the x with x bar, where the x bar is some dummy variable. So the upper limit, instead of the b here, let's say b here is equal to 1, previously you substitute it with some finite number 1. So in this case, you substitute the symbol x to indicate the variable. After you solve this, you should obtain some answer in the function of x. So for example, in this case, you obtain 8x. So you can substitute any x in this direction to obtain the corresponding arc length. For example, in this case, you substitute b equal to 1 where your x equal to 1. Then you obtain 8. So this gives the same answer here. Besides that, you can substitute the x to numerous number to find the arc length at different points. To find the arc length and arc length function, you need the dy over dx in these two formula. However, in some situation, integration that involve dy over dx might be more difficult to be solved than the one involve dx over dy. So we have more flexibility if we can compute the arc length by using the integration that involve dx over dy. So to do this, let's look at the previous formula, and in this case, we take out the square root of dy squared. So inside here, so your dx squared will remain, and it need to divide with the dy squared. And on the other hand, the dy squared here will gone, it become 1. The square root of dy squared here can be cancelled, and we move to back here where you obtain this formula. Since you are integrate with respect to the y-axis here, so the limit must be in the y-axis. So a and b are the limit in x-axis, so we cannot use it. So let's say here is the lower limit for the y-axis, and here is the upper limit for y-axis. So you need to replace the limit here for the y-axis limit. By doing this derivation, then you can obtain another arc length equation which involves the dx over dy instead of the previous dy over dx. This is the corresponding arc length function that can be obtained from this formula, where you can see the upper limit here is replaced by the y symbol, and then the y here is changed into y bar, which is the dummy variable. So you have two options to compute the arc length and arc length function. So these two approaches should give you the same answer. So when should we choose the option 1 or option 2 to solve the problem? So it depends on the dy over dx and dx over dy here. If you see that the integration of this function is difficult, then you go for option 1. If this is more difficult to be solved, then you go for option 2. So this is the way to choose it. In this example, you are going to find the arc length for this curve from 1 to 3. So the lower limit a is 1 and upper limit b is 3. And the function is given y equal to x squared. So to find the arc length, you need to perform the integration from the limit a to b with respect to the x-axis. And the distance is equal to square root of 1 plus dy over dx squared, where you can obtain the dy over dx here. Differentiate the y, you should obtain 2x. So you can substitute the a, b and dy over dx inside. Then you should obtain this, where you can compute the arc length by using this formula. Previously, you have learned that if you want to integrate some function with the square root of a squared plus x squared format, like this. So in this case, we will choose the x equal to a tangent angle. This is known as the trigonometric substitution method. So in this case, your x is in 2x instead of x. Therefore, you can substitute this formula to be 2x. And your a squared is equal to 1. Therefore, your a is equal to 1 in this case. So you can substitute your 2x equal to tangent angle for the substitution. And your x is equal to tangent angle divided by 2. So from this trigonometric substitution, we can plot the triangle, and then we should know the tangent angle is 2x divided by 1, where 2x divided by 1 is equal to the tangent angle here, where you can obtain the resultant, which is equal to 1 square plus 2x square, and then take the square root. So you can find the x equal to tangent angle divided by 2, and you can differentiate dx with respect to the angle, and you shall obtain the tangent into secant square. For the trigonometric substitution, not only the x and dx need to be converted into the angle, and the angle by using these two formula. Since the dx here will be converted to something in the angle later, therefore the integration limit will change as well with respect to angle. So from here, you can form the angle of the limit equal to the arctangent of 2x. By substitute the x and dx inside this formula, then you should obtain this. You continue to substitute x inside this formula, then you obtain the angle equal to this, and substitute 3 inside this formula, you obtain the upper limit equal to this. So this can be cancelled. 1 plus tangent square based on the identity is equal to secant square. Substitute inside, the square root can be cancelled. Secant multiplied with secant square, so you should obtain secant power of 3. So this is the final answer. And this is the simplification of this formula. We have solved this problem before, so the integration of the secant cube angle is equal to this answer. So we can substitute inside this and multiply with 1 over 2, give you 1 over 4. You can use the calculator to compute the arctangent 2 and 6 here to obtain this value. Be careful that the 2 and 6 here, the unit is in radian. Continue to substitute the upper limit inside, then you should obtain this. Minus with the 1, substitute with lower limit. After you perform the calculation, you should obtain this result. So this is the distance that you compute from here to here for this curved line. So the length is equal to this. Previously, we successfully obtained the arc length from x equal to 1 to 3 here by using this formula, and you obtain this solution. If you want to find the arc length function, then you can substitute the upper limit to be x and substitute the x function here to be x bar. So perform the calculation, then you should obtain this by using the trigonometric substitution that you used previously. So in this case, you can see that for this upper limit, you have arctangent 2x. By substituting inside, you should obtain this in the x function, and then you substitute the lower limit here. On the right hand side, if you compute this, you should obtain negative 1.479. From this trigonometric substitution, we know that 2x divided by 1 is equal to tangent angle. So 2x divided by 1 is equal to tangent angle here, and this is the distance for the resultant. So from here, we can find the secant, which is equal to 1 divided by cos angle. From this triangle relationship, square root 1 plus 2x squared, take the cos angle equal to 1. Therefore, 1 divided by the cos angle give you the square root 1 plus 2x squared, which is equal to this. You can see that the arctangent of 2x is equal to the angle. Therefore, tangent angle give you 2x here. So you can substitute the tangent angle to be 2x. And you have tangent angle here also. So this one will be equal to 2x as well. So you continue to substitute the secant angle, which is equal to this. So here you have secant angle, substitute inside. Here you also have it, substitute inside. So this is the final answer for the arc length function. By substitute x equal to 3 inside this formula for all the x, then you should obtain this result. So when you compare it with the previous arc length result that you obtained, they give the same answer. The advantage of having the arc length function here is give you the flexibility to find the arc length for various lengths. For example, if you want to find the length from x equal to 1 to 8, substitute x equal to 8 inside, then you can find the corresponding arc length. Let's solve the same problem by using the second arc length formula. So in this formula, we are using the dx over dy instead of dy over dx. And the lower and upper limit is in the y-axis because you integrate it with respect to y, and your c is equal to 1 and your d is equal to 9 here. This can be found by substitute the x equal to 1 inside this formula. You obtain your y equal to 1 here. Substitute x equal to 3 here. Inside, you should obtain y equal to 9. The next thing, you need to compute the dx over dy. So in this case, your x is equal to square root of y, or the y power of 1 over 2. When you differentiate it, you should obtain 1 over 2 y to the power of negative 1 over 2, which is equal to 1 over 2 square root of y. Substitute the CD information, you should obtain this, and then you should continue to substitute the dx over dy here. Take the power of 2 here, you obtain 2 become 4, square root y become y here. By taking the square root of 1 over 4 out, which is equal to 1 over 2 here, then this should be equal to 4, and this will be cancelled. So you should obtain this. To solve this problem, we can perform the substitution. Let the u equal to square root of this term, and then take the differentiation of u with respect to y. So after you differentiate this, 1 over 2 here, you need to multiply it, and this power will need to minus with 1. Therefore, you obtain 1 over 2 and negative 1 over 2 here. Then you need to continue to differentiate this component. Since this term is in the power of negative 1 over 2, then you can put it in the bottom here. Differentiate 4, which is the constant, give you 0. Differentiate the y power of negative 1, then you need to multiply negative 1 in front. Negative 1 become negative 2. So this gives you negative 1 over y squared. Since this square component is equal to u here, you can substitute to obtain this answer. Let's take the negative to the front and solve for the 1 over y squared here. So you can see in this, you have the 1 over y. So 1 over y is equal to u squared minus with 4. So 1 over y squared will be u squared minus 4 power of 2. Therefore, you obtain this term. Then we can convert this into this form, where you can see 1 over 2 remain, and the square root 4 plus this term is equal to u, so you can substitute u inside, and your dy can be found here. So dy is equal to du divided by this. So you have this here. When the lower limit is 1, where your y is equal to 1, substitute inside this formula, you obtain the lower limit for u, which is this. And when y is equal to 9, substitute inside here, then you should obtain the u equal to this. You can bring the 2u to the top and multiply with the u to obtain 2u squared, and the constant 2 here can be cancelled to get this. U squared minus 4 is u minus 2 multiplied with the u plus 2. So you have power of 2 at outside. Then you can continue to take the power inside to obtain this. Both of these factor is in repeated linear factor. Therefore, we can write it in the partial fraction form like this, where you have the u plus 2 square. In the linear factor, you have u plus 2. So this is the unknown coefficient A. U plus 2 square. This is the unknown coefficient B. So you repeat the same procedure for the u minus 2 square here, where you have the u minus 2 and u minus 2 square with the corresponding C and D unknown coefficient. Then you can find the unknown coefficient A to D here by using the partial fraction method. So this is the answer. Integrate 1 over u plus 2 give you the ln. Integrate 1 over u minus 2 give you the ln. Integrate 1 over u plus 2 square is same with integrate u plus 2 power of negative 2. After you integrate it, at the top you have positive 1 here with the negative 1 at the below. So you can see that the negative here need to multiply with negative 1 here to become positive, and this become negative 1. So u plus 2 negative 1 is equal to 1 over u plus 2 here. Similar method can be performed on this to obtain this answer. Once you substitute all the upper limit inside minus with the 1 substitute with the lower limit, then perform the calculation, you should obtain this answer. So compared to this arc length result with the previous approach, then you should find that we obtain the same answer. There is slightly deviation here due to the round off error. You can proceed to find the arc length function from this formula. So you can see that the upper limit is replaced by the y symbol, and the y here is replaced by the y bar. So you can proceed to solve this, and you should be able to obtain this result in the function of y. This function is very useful to find the arc length from 1 to any y position. For example, if the y is from 1 to 9, you want to find the arc length here, then you can substitute y equal to 9 inside this formula, and you should compute the arc length equal to this, which is close to the solution here. So if you want to find the arc length from 1 to 40, you can substitute the y here to be 40. Then you can find the arc length from y equal to 1 to 40 here. So the curve length here will be equal to this result. All of us are familiar with the circumference for a circle is equal to 2 pi r, where the r is equal to the radius. But how can we get this formula? So the founder, who is known as the father of pi, used the numerical approach here, where you can see to approximate a linear line to a circle, you need to increase the number of segments. By doing that, you need to reduce the step size between 2 points where the delta x approach 0. Then the summation of all the infinite linear line here will be equal to the circumference of the circle. So you have learned the arc length formula, which can be represented by using these two approaches. So we can try to estimate the circumference of a circle by using this formula. We know that for a circle with the center at x equal to 0, y equal to 0, has the following equation. So from here you can find the function y, which is equal to r squared minus x squared, and take the square root. So for the upper part, it will be positive, and for the lower part, it will be negative. So let us consider the upper part only. Therefore, we only consider the positive function here. Since the y is equal to the fx function here, you can differentiate it to obtain the dy over dx. So you have a power of 1 over 2 here. After you differentiate, you need to multiply with 1 over 2. And then the power here will need to minus 1, which gives you negative 1 over 2. Therefore, you obtain this component. So don't forget to differentiate the component inside here, where the constant becomes 0, negative x squared. After you differentiate, you obtain negative 2x. So this is the differentiation result. You can further simplify this by cancel the 2. Then you obtain this. After that, you substitute inside the arc length formula to obtain this, and the lower and upper limit can be obtained from here, where you can see a is equal to negative radius and b is equal to radius. So you can continue to take the power of 2 here to obtain s squared at the top, and the square root can be cancelled. So you can let 1 equal to this, so you can take the summation of these two terms. So after you take the summation, these two terms can be cancelled, which gives you this answer. So you can see that square root of r squared can be cancelled, give you r, and you only have this remaining term. So in this format is in the a square minus x square format, where we can use the x equal to a sine angle to solve the problem. So in this case, when you compare a square with the r square here, then a is equal to r. So you can substitute the a to be r here. So you can differentiate dx with respect to the angle, which give you r cos angle. So we need to convert the lower and upper limit here to the angle, because later you are going to integrate with respect to the angle. From here you can find the angle equal to r sine of x divided by r. So you can substitute the x equal to r inside this formula, give you the upper limit in this form, and you can substitute the x equal to negative r inside, give you the r sine negative r divided by r. By using calculator, r sine 1 give you 1.571, and r sine negative 1 here give you negative 1.571. So you can replace this to the upper and lower limit, and you can replace the dx from here to be r cos angle d angle here, and then x here you can substitute the r sine angle to obtain this. So we can further simplify this by taking the r square outside to obtain square root r square, and this will become 1 minus sine square angle, and we know that 1 minus sine square angle give you cos square angle. Cos square angle, if you take the square root, then you only obtain the cos angle, and cos angle can be cancelled with this, and this one you can multiply with r to obtain r square. Then here you have square root r square, so this is, you need to take r square divided by r, so in total you only have r here. Integrate the r with respect to the angle, you obtain r angle. So you can substitute the upper limit minus with the 1 substitute with lower limit, then you should obtain this final answer. So this is the circumference for the upper part here. So far we have success to obtain the circumference for the upper part to be this answer. Since the lower part is symmetry with the upper part, therefore the circumference should be the same. So the total circumference for a circle can be equal to 2 multiplied with the circumference 1 here. So substitute inside, you should obtain this answer. And the coefficient 3.142 and so on here is known as the pi value. And 2 multiply radius give you the diameter. So for any circumference for a circle, it will be equal to pi multiplied with diameter. In summary, for any circle with the diameter equal to d here, let's say we cut it off and arrange the circle into a straight line. So by calculating the distance from here to here, actually we are computing the circumference for the circle, or is known as the arc length of the circle. For any diameter of d here that you can measure, multiply with the constant for the circle, which is the pi, equal to 3.141 and so on. It gives you the circumference for the circle. And bear in mind, the pi value here is an important coefficient for a circle, and this value can be obtained by using the arc length formula, as shown in this example.